Okay, it looks like we are ready to go. Hi everyone, and welcome to another webinar by JScrambler, where we will explore the topic of third-party code risk. With this in mind, today we will be looking at an overview of client-side code and how it is being leveraged by attackers. We will also explore approaches like content security policy and some more useful strategies that can be used to gain visibility and control over your platforms. I want to start by letting you know that this webinar has been pre-recorded, so if you have any questions, you can reach out to us at hello@jscrambler.com and we will get back to you as soon as possible. Okay, before we move forward, I just want to present our speakers for the day. Today we have Pedro Fortuna, who is the CTO and co-founder of JScrambler, and Filipe Pereira, who is the head of engineering also at JScrambler. And I'll go right ahead and give the floor to Pedro to get us started. Thanks, Pedro, and feel free to take it away.
Thanks, Filipe. Hi, everyone. As a security researcher, over the last 15 years or so, I have been focused on application security. And recently, I've been observing how attackers are taking advantage of the lack of client-side security to breach websites and inject arbitrary code. The reason why this happens is because there is large attack surface from different parties. The typical web application contains a huge mashup of client-side code. With all the frameworks and libraries that are used during the development of these platforms, come dozens of pieces of third-party code. And this third-party code is able to pull fourth-party code, and so on. So this creates such a long chain of code dependencies, and companies don't really have a good way of having visibility on what code they are effectively running and what the code is actually doing. So a lot of sensitive data in flight passes through the client side, as it's pulled from the database and displayed to the user, or as the user types it into a form. All of this data is at risk of being leaked. More traditional security approaches, such as server-side security or firewalls, do not contemplate these client-side security weaknesses. And as I will explain later on, even browser security mechanisms are falling short to shield websites against client-side attacks. So when we look at the numbers, we see that 70% of the codes in the average web app is being sourced from third parties. And with 35 third-party components and 31 on average fourth-party components, you can imagine just how complicated it can get. So on the left here, I have a simple illustration of a web app that is using third-party scripts. An example of a script could be a live chat widget or any type of plugin. Let's say this foo.js file is a part of a live chat widget, and someone gained access to its repository and managed to inject malicious code into it. Because this change can happen without any visibility from the provider of the chat widget, the malicious code will silently ship to all the users of this live chat, including our own website. So when that happens, we will inadvertently start serving this malicious code to our website visitors. The same happens when we have a fourth-party script like bar.js that is compromised. The malicious code will make its way down the supply chain, reaching the other .html file, meaning that will end up running on our website as well. Having arbitrary code running on our websites is especially dangerous because all scripts have the same power. So just like our first-party scripts, any of these externally sourced scripts are free to do anything on our website. They all have the same power. So attackers can use our compromised live chat widgets to harvest user inputs in any form that we provide, including login forms or payment forms. They can also add additional code to the web page, hidden in plain sight. For example, to display a fake pop-up for phishing purposes, or to redirect the user to websites containing malware. With that, attackers can then readily exfiltrate any data they have collected and send it to a drop server under their control. You can already imagine the consequences of allowing attackers easy access to the credentials or PII of your users. With strict regulations like GDPR and CCPA, this is a clear violation of users' privacy rights. And when it comes to payments, for example, this directly poses a violation of regulations like PCI DSS. Apart from this, there's also the damage to the company's reputation, which can result in business losses and leave a permanent dent in the relationship with customers. Well, I placed some news clippings here to show you that this isn't just theory. Over the course of the last few years, we have seen some major attacks and data breaches that resulted precisely from attackers targeting third-party code. Script-based attacks have been used to backdoor cryptocurrency exchanges and digital wallets. In some cases, this was done by inserting malicious code into open source software, and this malicious code eventually made its way into official product builds. Still, Magecart is probably the most well-known example of this type of approach. One noteworthy example is Ticketmaster attack. It was breached by a Magecart web skimmer in 2018. Attackers placed the malicious code on a third-party chatbot from Inventa that Ticketmaster was using. With this attack, they were able to steal the credit card details of about 60,000 users. These Magecart attacks are resulting in some of the highest ever data breaches fines, as privacy watchdogs are not taking it lightly when thousands of users are having their private data exposed. According to RiskIQ, Magecart attacks have risen by 20% during the pandemic, a time where we also saw a huge increase in online shopping. In the US, online shopping grew by 49% in April 2020, and this volume has presented a unique opportunity for this type of attacks. Other research shows that there has been 2 million web skimming attacks so far, with 20,000 compromised websites. But the most important statistic is this last one. A web skimming attack remains active on average for 22 days before being detected and removed. We have seen some cases where 6 or more months go by without companies being aware that their websites are infected, which confirms our main premise that companies have no visibility on what's going on at the client side. In an attempt to address these threats, many security teams are turning to content security policy. In case you're not familiar with CSP, what it does is lets you define which external sources your website can connect to. You whitelist the sources you trust, and every other connection will basically be blocked. Looking back at our diagram, CSP essentially covers the network dimension. So every allowed script will be able to load, along with any fourth-party scripts that they load themselves. CSP will then allow any type of data to be sent to these whitelisted domains. But many of these security teams that I've talked with typically understand early on that CSP is not the right answer to client-side attacks like Magecart and data exfiltration. There are just too many possible ways to bypass CSP. According to the findings by Google security researchers, roughly around 94% of the first generation domain-based whitelisting CSPs are bypassable. But even if we get past that, CSP can actually prevent data exfiltration. Going back to the Ticketmaster example, for instance, if they had whitelisted the Inventa chatbot domain on their CSP, they would have ended up with the web skimmer anyway. And plus, attackers can also find ways to exfiltrate data by routing it through an approved domain before sending it to the final destination, the drop server. If instead we block these trusted domains, we will end up breaking things and ruining the whole application. So it's very tricky to maintain CSP. Finally, a definite showstopper for CSP is that it is not granular at all. Like I mentioned before, once we allow a certain script, it will be able to do anything it wants to. So we can prevent it from sending specific types of data to external domains. There is no middle ground. It's an all or nothing thing. So if CSP is not the answer, what is? Well, the first thing we have to have in mind is that script-based attacks haven't stopped evolving. When we take a look at recent examples, we see that they are using very advanced obfuscation techniques and sophisticated defense mechanisms like bot detection code to avoid being detected. So what does all of this tell us? Well, first, browser security by itself is surely not enough. Effectively detecting the scripts means leveraging several different techniques, such as sandboxing, poisoning detection, and DOM tamper detection. Plus, it must be able of doing both static and dynamic JavaScript analysis and use the best possible deobfuscation techniques to uncover obfuscated scripts like web skimmers. And finally, because attackers would try to interfere with any solution that is actively trying to do all of this solution must also include resilient code protection to prevent tampering attempts against the solution itself. Gaining visibility of the client side will allow us to answer these important questions. Not only what scripts we are running, but where they are running and where they have come from. And not only asking what network requests they are doing, but actually figuring out which scripts are doing these requests, where data is being sent to, and more importantly, if this request should exist in the first place. If we are actively looking for these signs, we will quickly find some red flags. For example, if the script of a live chat starts messing with a payment form, that's a clear indication that something is wrong. So now I want to give you an overview of how we are addressing this problem with JScrambler web page integrity. The first step is real-time visibility. Like we saw before, a malicious script always displays at least one sign of malicious activity. By sandboxing its script, we can start observing its behavior in real time and look at these signs. For instance, we will know if a script is loading additional code or accessing form data and then sending this data out to a suspicious domain, which is the case of Magecart web skimmers and data exfiltration attacks. We can also observe if the script is mutating the DOM or attaching to DOM events. For example, a script that changes the DOM to display a fake banner that tricks users into accessing a phishing page. Essentially, we will have full observability over any given script. This all translates into reports of possible client-side threats. Here I have two different views that web page integrity provides. So on the left, we have a live feed of every possible threat, and then we can see the details of each detection, including the call stack. But of course, with so much happening on the client side, we can quickly reach thousands of detections, making it very time-consuming to go over each threat. This is why we provide aggregated views. So the first image we see here is an overview of similar detections grouped together, which allow us to see, for example, how many times each instance has been detected and how many different IPs it has affected. Below, we have an inventory. This groups all the scripts and network requests that have been loaded or changed something on our website. And before I move on to explore the inventory in more detail, I just wanted to mention that we also provide dedicated support to help manage these alerts and configure them for each specific use case. The inventory we provide also allows a straightforward vetting of scripts. This is very useful when it comes to onboarding new scripts, as they will first show up as unclassified. We can review the scripts carefully before marking it as classified. Of course, this also allows us to easily identify malicious scripts and figure out which rules we want to enforce to prevent these and similar scripts from tampering with our website. And this brings us to the second part of this webinar, which is control. After we understand the specific threats we want to prevent and the different scripts that are running on our platform, we can define a set of rules to control their behavior. In the case of web page integrity, we provide rule-based script fencing, which gives flexible control over these behaviors. For instance, we can whitelist a series of high-level behaviors for scripts, for specific scripts, which, unlike CSP, we can partially allow a script by default and block disallowed behaviors. The same is true for destination domains and network requests. Another example is that the one we see on the left here. So in our login page, if any script has a target that equals form, it will be blocked. This is especially useful to prevent any script from retrieving users' credentials. When we boil this all down, script fencing is the most effective answer to third-party code risk. So while CSP only addresses the network components and can only completely allow or disallow a script or domain, with script fencing we have full control, both through high-level rules and high granularity rules that look for specific behaviors. And here I have multiple examples. So we can sandbox this evil.js script, only allow it to run on a specific page and prevent it from adding fourth-party code. Then we can enforce behaviors on all of these different dimensions, like only allowing it to access specific form fields or preventing it from modifying other JavaScript code. Okay, now that I've explored our approach in some detail, I'll move the floor over to Felipe Pereira. Thank you.
Thank you, Pedro, and hi everyone. I'm currently working with several web page integrity clients, and today I would like to share with you a little bit of the knowledge and what's happening in these customers and what they are being able to achieve with our products. But before we go there, I just want to make some notes about compliances and regulations, because this is a major concern that all of these companies share. Obviously, if you work on finance, and you have any website or mobile applications that handle payments, the regulations are a must, and you need to keep up with them. I think it's interesting to mention that most of the recent updates to compliance and regulations are mandating this kind of monitoring systems that allows you full visibility on what's going on with your application or website. For instance, GDPR requires you to put in place measures to avoid leakage of sensitive data from the client side. And that's why, for example, British Airways was fined in the first place, because they lack this type of visibility. It just took like 15 days for attackers to collect roughly 380,000 credit cards from their website using a web skimmer. So you have to put mechanisms in place to prevent this. If you use technology that is able to give you visibility and control over these scripts, you'll probably be able to mitigate and prevent most of these attacks. However, even if it fails, because sometimes it's not possible to block everything and to prevent everything on time, it's still possible for you to manage this risk and be able to prove to auditors that you have done everything in your power to detect and to monitor, so the risk of getting a fine is much lower. PSD2 and similar banking regulations are another great example. They mandate the detection signs of malware infections on the client-side devices, and that the application has not been tampered with and might be able to collect sensitive information. So the takeaway is that in order to protect the data, one needs to continuously monitor the client side for any signs of malicious behavior to make sure that the third-party script doesn't blindside us and starts exfiltrating data. I just want to also to mention PCI DSS because it outlines security best practices to protect cardholder data. And one of the key requirements of this certification or this standard is to deploy a change detection mechanism like file integrity checks and monitoring, and to generate alerts to personnel that if an unauthorized modification has happened. So if a third-party script, for example, starts injecting arbitrary code, you must be able to detect this in real time and take the necessary steps to contain the attack real time as soon as you can. Then, of course, we have other certifications in different markets, like HIPAA for healthcare. But in general, they all target the same thing. So, which is the need to detect malicious behaviors and mitigate these attacks to prevent data exfiltration, and that's achievable using monitoring of all your websites and mobile applications. So now to talk a bit about some interesting findings on our webpage integrity clients and what they were able to achieve with the usage of our products. So one of the common denominator is that they are discovering things that they didn't expect. So this is remarkable because, of course, they have their own goals for the tools. They buy it for a certain purpose, but in the end, they were able to find much more than they expected. For example, they were able to detect a known XHR communication on their own code, which was sending data out to domains which they did not expect, and they were not in control. So this is critical, of course, because you might be leaking private data, PII data, or sensitive data outside to a different company that you were not expecting or not in control. We also had some other teams that were seeing some strange behavior happening on the webpage, and when they tracked it down, they ended up finding legacy code that was poorly managed and that was potentially posing a security risk. So this is more common than it should and expected, but companies sometimes have code with many years, so it's very hard to keep track of what actually is happening on the client side. Another very common feedback we received was that some third-party scripts, like injecting by the marketing teams, were not really in control by the development team. So they might be collecting data that was not expected and not in control, or even handling data in a way that it was not expected. So now they are, of course, using webpage integrity to make it easier to onboard these scripts and really detect what the scripts are doing, which data they are collecting, and to where they are sending this data, just like Pedro mentioned before. And finally, there were also some third-party leads that they found out that they were doing things in an uncontrolled, insecure way. So, for example, they were using GET methods to pass sensitive data to a third-party domain and not using the best practices that was supposed to be. And of course, that's a risky situation, and they had to act on it and change the third-party libs. One particular case I would like to mention, which is one of our most recent success stories, is about a major airline. And they bought WPI to be able to mitigate Magecart and wanted to prevent to become the next British Airways. So they wanted to know if any of their scripts change behavior and to have the ability to block any web skimming attempts. they wanted to have the minimal impact on the performance, since this is very tied to their revenues. So they wanted to be able to use the product in a seamless way with barely near to zero impact on the product. And of course, they wanted to have the ability to send all the notifications and all the alerts to their CM so that the security team could act on it. So they were able to implement web page integrity successfully, using our behavior detection and control to detect and mitigate any type of skimmer. Our approach passed on all their tests, so they had very thorough and detailed tests to check the capability of detecting specific malware and poor behavior on the client side, and we were able to pass on all their tests. They also use our inventory of scripts and network events to get a clear picture of what their platform, how it's acting at any given time at any given point in time. And of course, our dashboards allow them to see any malicious behavior. Since it's already classified by severity, they are able to look at what is really most important, what is happening on the client side that is more relevant and should be acted upon. So another comment they made was that it was very smooth to transition from a POC to a production environment. No hiccups. The integration was very simple, very easy to do. So they were very happy for that. On generic customer insights, so with this, they were able to increase the visibility on how clients now have their client-side scripts. The overall feedback we are getting is that they are now much more in control of what happens there. There's a high impact on security awareness from day one. And there's like a feedback loop. So they are able to see what's happening on the application on the client side. This is very valuable information for the development team to improve their development best practices, to guarantee that there's no security vulnerabilities on the client side, and be able even to block and prevent situations that were not expected. And as I mentioned before, they are using web page integrity to improve how they handle some internal processes, like the onboarding of new marketing scripts. So they review their internal process to make sure that all third-party scripts are onboarded according to well-defined procedures. Circling back to regulations, they also mentioned that this increased visibility and controls, and they are more in control and making it easier to demonstrate like PCI compliance or even data GDPR compliance. So that was it. I will move things to Pedro so he can give us some closing remarks, and thank you.
Thanks, Philippe. So to sum it up, we saw that script-based attacks are evolving fast and becoming much harder to detect. Attackers are taking advantage of client-side blind spots to infiltrate websites through third-party code. This is allowing them to go undetected for a long time. While many security teams first turned to CSP, they eventually realized that it lacks the granularity and robustness required to deal with these sophisticated attacks. To beat attackers, we must gain full visibility of client-side scripts and also be able to control them with full flexibility, not just the binary all-or-nothing approach that CSP uses. JScrambler Web Page Integrity provides this flexibility through several detection techniques and by sandboxing external scripts, giving real-time visibility of the behavior of each script. Using an inventory and rule-based script fencing, it becomes easy to fully control what each script is allowed to do, blocking any type of malicious behavior like data exfiltration. Well, I think that it's all from my side. Thank you.
Thank you again, Pedro and Felipe, for your valuable input. Before we finish, I just want to remind everyone that you'll receive an email with our datasheet on web supply chain attacks, which gives an in-depth explanation of the topic of third-party code risk. As I mentioned earlier, if you have any specific questions, feel free to reach out to us using the email you see here. We will also be offering on-demand access to a free web application inventory, so get in touch with us if you're interested. And well, that's it from me. Thanks everyone out there for joining us today, and see you next time. Bye-bye.